Hey everybody, this is Pre-Calculus Inequalities Part 3. This is going to be about inequalities involving non-continuous functions. So that means functions where there's breaks in it. So a continuous function keeps going in a line like that, right? Keeps going forever and ever. Where a non-continuous function might have a piece like that and then another piece that goes down like that, right? And we learned about that already. All right, so this one is going to be done just the same as when we're solving continuous functions, except for one additional part. So when there are points of discontinuity, that's going to mean breaks in your function, it's solved as in the case where it's continuous, but with one addition. We add the points of discontinuity to the list of possible endpoints of the intervals, okay? So generally, when we have a continuous function, right, and let's say that here's our zero line, we're going to look at this to this is an interval, from here to here is an interval, from there to there is an interval. Alright, but if we have one that has discontinuity, that means some breaks in the function, right? So let's say here's our line, and we've got one that goes like that, and then another one that goes like that, right? Or maybe, I don't like that last line, let's erase that. The other one goes like, it stops there, and then that one goes like that, right? So we're going to have a break there. There's going to be an interval that doesn't exist. And we have to add this piece right here in. Okay, the easy way to do that, it's easy peasy, we got to find out what our discontinuities are and put them in with our points. And the way to do that is figure out the numbers that make the denominator of the fraction 0. So these are just going to be ones that have a fraction. So this one says solve the inequality. We got x minus 1, x plus 2, and then we've got this on the bottom, right? So we got to figure out what makes that be 0. We can't have 0 on the bottom of a fraction. That's going to be our point of discontinuity, right? So where there is no answer. So all we have to do is set that equal to 0. So we say x times 2x minus 9 equals 0. Well, this has two possible answers, right? Each of these pieces could be equal to 0. So if x could be equal to 0 and x, let's see, then we would have 2x minus 9 equals 0. So we'll do plus 9, and we're going to get 2x equals 9, divide by 2, divide by 2. So other one would be x equals 9 over 2. These are what are going to make this function non-continuous at those 2 points, right? So there is no answer at 9 over 2 and at 0. Okay, so we're going to add that to our list. Then the other parts where it would be 0, any of these tops would be x minus 1 equals 0. So we would do plus 1 plus 1. X equals 1. So that's our other point. Okay, and then we also have x plus 2 equals 0. So x plus 2 equals 0, minus 2, we will get x equals negative 2. Okay, so now we have 4 different points on our graph where it's either going to be touching 0 or it stops, right? So those are our stopping points. And when we're doing this, we need numbers that are greater than or equal to 0, so this is positive values that we're looking for. All right, so let's make our intervals. Our first one's always going to start with negative infinity, and then our lowest number, which would be negative 2. Then our next one, and anything that's related to this top, since it's greater than or equal to, right? So these two values are going to be in brackets instead of roundies because they're greater than or equal to. So this needs to be in a square bracket. So our negative 2 goes into a square bracket because it's greater than or equal to, right there. That's only for our tops. It doesn't count for the bottom where it's equal to 0. All right, next one would be from negative 2 to 0. That will be rounded because it's over on this side from our 0 bottoms right there, our discontinuity, right? And then we got from 0 to 1, and our 1 needs to be a square bracket. because it could be equal to 0. And then we're going to have from 1 to 9 over 2. And if it makes it easier for you, you could say 9 divided by 2 would be 4.5. So you could just kind of make a note to yourself. 9 over 2 is the same thing as 4.5 or 4.5. Okay. Alright, so here's our intervals. Oh, we got one more. 9 over 2 to infinity. Positive infinity. Okay, so now we're going to pick a number for each of these, and we're going to double check them to see if they fit into here and make this positive. So we just need positive values. Alright, so any random number between anything less than -2, so I'm going to say -3. Between -2 and 0, I'll say -1. Between 1 and 0, I'm going to have to go with 1/2. 0 and 9, or 1 and 9 over 2. 9 over 2 is 4.5, so I'm just going to say 4. And then anything more than 4.5, so I'm going to say 5. Alright, so first I'm going to check for -3. So if I put a -3 in here, 3, -3, -3, and a -3. I have -3 minus 1 would be -4. Okay, and -3 plus 2 would be -1. Negative times a negative would be a +4 on the top. And then my bottom would be -3 times 2 would be -6 minus 9, which would be -15 times -3. It's going to end up positive. 15 times 3 would be 45. 4 over 45. All we're really looking for is if it's positive or negative. And remember, we're looking things for positive values. Okay, this is positive because all of our negatives cancel with each other. So that's a positive value, so that one checks out. Alright. Let's try the next one. Okay, -1. So if I said -1 minus 1, I'm going to have 0. No, I'm going to have -2. Oopsie. -1, -1 will be -2 right there. And then -1 and 2 would be +1. So this would be -2. The whole top is -2. Okay, and the bottom, -1 times 2 would be -2, and -2 and -9 would be -11 times -1 would be +11. So this whole thing is negative, and we're looking for positive numbers only, so that one does not work. Okay, next one. So all I'm doing is taking a random number from in the interval and I'm plugging it in just like we did in the last one. Alright, 1/2. 1/2 of -1 would be 1/2 minus 1 would be -1/2. And then 1/2 plus 2 would be 2.5. And so that's a negative times a positive. It's going to be negative on the top. Right, and then we have 1/2. 1/2 of 2 will be 1. 1 minus 9 would be -8. Times 1/2 would be -4. Negative times negative makes a positive, so that is positive. So that one works. Okay, next one is 4. 4 minus 1 would be 3. 4 plus 2 would be 6. 2 times 4 would be 8. Minus 9 would be -1 times 4, which would be -4. And 3 times 6 is 18. So we got 18 over -4, which is negative. So that one does not work. And last one is 9 over 2. That's 5. So 5 minus 1 would be 4. 5 plus 2 would be 7. 7 times 4 is 28 on the top. And then 5 times 2 would be 10. Minus 9 would be 1 times 5. Right, because that's 5. 5 times 1 is 5. 28 over 5, that is positive, so that does work. Alright, so that shows us which intervals we have. And then when you write your answer, you're going to do it just like in the last part. So this one would be negative infinity to negative 2, and this has a square bracket because it's greater than or equal to. And then we would have 0 to 1, square bracket on that one. And then the last one, it would be 9 over 2 to infinity. Right? So don't include these ones that didn't work. We'll include these 3 that did work. Alright, and that is all they have for examples. Make sure you're putting the union symbol in between there. All of the homework is going to be multiple choice, so you get to pick. Alright, I'm going to work a random one from a different worksheet. X plus 3 times x plus 5. Alright, so this one has x plus 3 times x plus 5 over x plus 2 is greater than or equal to 0. X plus 2 is greater than or equal to 0. So I need positive. Right? And then my one that can't, my discontinuity would be x plus 2 is not equal to 0, right? So we do minus 2, and we get x equals negative 2. So my discontinuity is negative 2. Right, and then for my top, both of those factors would have to be equal to 0. So if I had x plus 3 equals 0, I'm going to get negative 3. And if I had x plus 5 equals 0, that would be negative 5, right? Because if I do minus 5. Okay, so those are my numbers. And the ones that are going to have the square brackets are the ones on the top part right here, right? So that's going to be, these two are going to be square bracket. This one's a roundy bracket, okay? Alright, so now I need to set those up in order with my intervals. So the first one would be negative infinity to negative 5 with a square bracket. And then negative 5 to negative 3 with a square bracket. Negative 3 to negative 2. And then negative 2 to infinity and beyond. Alright, so right here I'm going to use negative 10 because that's an easy number to deal with. This one would have to be negative 4. This one would have to be negative 2.5. And this one I'm going to say positive 5. Alright, now I'm just going to plug these in. So if I plug this one into the top, I would have negative 10 and 3 would be negative 7. And then negative 10 plus 5 would be negative 5. And then 7 times 5 is 35. Those will cancel, and I'd have positive 35 on my top of my fraction. And negative 10 plus 2 would be negative 8. So that is negative, and I'm looking for positive values, so that one does not work. Double check. Yeah, does not work. Alright, and then I'm going to plug in negative 4. So if I've got negative 4 plus 3, hang on, let me erase my workspace here. I've got negative 4 plus 3, that's going to be negative 1 for that first part, right here, okay? And then if this was negative 4 plus 5, that would be positive 1. And then negative 4 and 2 would be negative 2. So this would be negative 1 over negative 2. These negatives cancel, and I get positive 1/2. I'm just looking to see if it's positive, and it is, so that one checks out. Okay, the next one is 2.5. Negative 2.5. Alright, so if I got negative 2.5 plus 3, that would be 0.5 positive. And that would be 2.5, right? So 3 minus 2.5 is 1/2. And then 5 minus 2.5, because negative 2.5 would be positive 2.5. Alright, half of 2.5 will be 1 1/4. Okay, and then 2.5 plus negative 2.5 plus 2, that would just get rid of the 2, so I would have negative 1/2. So this is a negative and a positive. That means this whole thing's negative, and it does not work. All I'm looking for is to see if it comes out negative or positive on these. Okay, next one is 5, and this last one. Alright, so 5 plus 3 would be 8. And then 5 plus 5 will be 10. That's going to be a positive 80 on top. And then 5 plus 2 would be 7. That's all positive, so that one does check out. So our answer is going to be negative infinity. No, that one didn't work. Never mind. Negative, it's going to be this one right here and this one right here. So negative 5 in a square bracket, negative 3 with a square bracket, and then our union, or it's called a cup, negative 2, infinity, and there we go. Write that a little better, a bit neater. Alright, not super hard. Just figure out what your intervals are, and then test them each out, and usually it's every other one that's going to work. Alright, I want to do one more type of problem, and that's where it's not set to 0, it's set to a number instead of 0. Let's erase all this, and I'll work one of those. Oh, this takes forever to erase. Sorry, guys. Okay, so let's see, what do we got that, whoops, the test. One where it's set to a number. Alright, x plus 32 over x plus 6. Is less than or equal to 3. Okay, so first I'm going to find my incontinuity, which would be x plus 6 equals 0, right? It can't equal 0, so that would be negative 6. That's my first number, my incontinuity. Now, I have to put this whole thing, I'm going to take that inequality sign, I'm going to make it an equal sign, so I'm going to say x plus 32 over x plus 6 equals 3. Alright, now to get rid of this x plus 6 on the bottom, I can multiply this side times x plus 6, and I can multiply this side times x plus 6. These are going to cancel. I'm going to get x plus 32 equals 3 times x would be 3x, and then 3 times 6 would be 18. Now I'm going to put my x's together, and I'm going to get 2x right there, and then I'm going to subtract this 18. And let's see, 8 and 4 is 12, 14. And then divide by 2, and I get x equals 7. Alright, see how when it's not equal to 0, I have to work the whole thing out. Alright, so I've got negative 6, and I've got positive 7. Alright, so those are my two numbers. So now I'm going to set up my intervals, and then test to see which ones work. Okay, so my intervals are going to be first negative infinity, and then my -6, and that is a rounded bracket because that's related to my bottom number. Then I'm going to have -6 to 7, and that's a squared bracket because it's lesser than or equal to 3. And then I'm going to have 7 to infinity. Okay, so now I need to pick some numbers. So I'm going to say -10 looks pretty easy. That'll be 0. Anything where you got a negative and a positive, I always use 0. It's the easiest. And then I'll use +10. Alright, so if I plug -10 in there, let's see what happens. So if I had -10 and 32, I would end up with 10 minus 32, 22, over -10 and 6 would be -4. Is that less than or equal to 3? Yeah, it's a negative number, so it's definitely less than or equal to 3. Let me make sure that's right. Yep. So that one checks out. It will work. Okay, next we're going to try 0. So 0, if I had 0 plus 32, that would be 32. And if I had 0 plus 6, that would be 6. Is 32 over 6 less than or equal to 3? Let's see, 32 over 6. 6 times 5 is 30, so that'll be 5 and 2, 6, which would be 5 and 1/3. Is that less than 3? No, it is not. So that one does not work. Alright. And the last one we have to check is the number 10. So I'm going to put 10 in here. 10 plus 32 would be 42. And then 10 plus 6 would be 16. Is that less than or equal to 3? Let's see, 16 times 2 would be 32. So that would be 2 and 10/16. Yes, that is less than 3, so that one checks out. Okay, so to write our answer, we're going to use the two intervals that worked. So that would be negative infinity and -6, both of those rounded brackets. And then we're going to put our union and then our square bracket for 7 and infinity with a rounded bracket. That's what your answers are going to look like for these kind of problems. Alright, I hope that made sense to everybody. It's just like the ones we were doing, except for first you have to find what's going to make your bottom of your fraction 0. That's your incontinuity, and add that to your list of possible numbers. Alright, thanks for watching.